Okay, let's see. It's visited since the last jump generation. Well, it's not highlighted. Why not? Ctags. Visited equals jump generation. Well, that means that set visited must have been called on this node since the last jump. Suppose set visited was called, and then we call jump. Then the jump generation is increased. So, well, increasing this means we have a new value for jump generation. And that's what we pass to is visited since last jump. So that means that it will always return false. For any node, except nodes for which this was called set visited. After that increment. It is only called here. That's not enough. Well, maybe it is enough. This is the only place where a current index can be changed. So any change of node, meaning that current index is changed, the current index should only be changed in this function. Set current index. That appears to be the case. Okay. So every time we go to a new node, we call set current index, which then, well, the current index here defines the current node that we are in. This means an error, so let's ignore that for a moment. And if set current index is called, then also set visited is set, which means that then we can jump to it. No. Well, at the very least, is visited since last jump is then will then return true. set current index. So let's see what that is called. Start from the top. Set current index is called in the constructor is the initial node. And although that is then the current index, I do not want it to be, it should not really be possible to jump to it. So I think that what I probably should do is set this to 0 here. And then set the jump generation to 1 here, so that it's not possible to jump to the start. Actually, now think about it. It's not that easy, is it? There are two types of jump, unfortunately. Yeah, no, I definitely, I don't want okay, what the fuck. Suppose we start in the current node, and then I'm not allowed to jump to that same node. Then I go to the next node, and then I go to the next node. Then we have, let me type that out. So this node here is the first node, let's call that A. And then we go right to B, and then we go right to C. Now it would be perfectly fine to jump back to A, because if A is a minimum, and it must be a minimum, it's the first one. Then B is a maximum, and C is a minimum, and for some reason we want to jump, then we could jump, then we would jump to the best minimum, and A could be a better minimum than C. Now this program doesn't know anything about minimum and maximum, but that means that from A we are not allowed to jump to A, but from C we are allowed to jump to A. I guess it translates to having the same jump generation, but not allowing ourselves to jump to ourselves. So we are setting the jump generation of A to 1. Then we are not allowed to jump to A though. Then we go to B, we never jump from B. Then we go to C, now we can jump again, and then we are allowed to jump to A because the jump generation is still 1. Now this one should then be set to 2, with as a result that now we are not allowed to jump to ourselves, but we are also not allowed to jump to 1. And the reason for that is that in reality the only reason we would jump from C to A is when C is a worse minimum than A, and we want to jump to the best minimum. So that's never going to be a minimum that already existed before the last jump, because that last jump is to the best minimum. However, it would be possible that now we add a new node, which is a minimum, and that could be better, and then we are allowed to jump to that node. Yeah, that's the idea behind this. So in terms of the jump generation then, this initial node is going to be set to, it's going to call set visited immediately with the jump generation of 1. And then set visited simply sets visited to that jump generation. And we use the same jump generation if we go to the next node, from A to B, for example, because that means that all we do is call set current index with index 1 higher. And then again 1 higher, and every time the jump generation did not change. But if we do an actual jump, then the jump generation is increased, which at that moment means that the node that we jump to must have set visited called again with a new jump generation. So if we do a jump, then set current index must be called after incrementing jump generation. So I'm going to go back to jump. Now it seems to be true because first I increment the jump generation and then we call set current index, which then calls set visited and so on. However, that also means that the code that decides to jump somewhere must take into account that the jump generation is current for the current node, and we are not allowed to jump to ourselves. So whoever is calling jump which is only here, should never jump to itself, which means that jump target must never be equal to the current. So this is only allowed if j is unequal current index. We need to use the same Boolean expression here. In this case, however, it is I. So if I is unequal current index. Hello, checking tips. Now I have a problem because there is another case, that is this case here, where we are, I mean, I here is the choices that we have. So this is run. We have a state machine and we run it to the end in this function. Is a reference to the current node, which is just the node from the array with index current index. If that current node has already been explored left and right, then we're done. That is, if it has an even index, that would mean a minimum. If we are in a maximum, so if the index is odd, then that is an error, which I want to find. You know, when does that happen with the current algorithm? If we are in a node, so the current node is not explored to both sides, then we get here. Then first we find out how much ways to advance exist. And there's always one, it says here, because that would be just going to the next node in the current direction that we are doing. And all the other possibilities that we're adding here, this increment, are for the cases where we might jump and well to a better minimum, aka an even index that we have visited since the last jump. So if the current index is even, then we run over all nodes, well, all even nodes. And if that is not the current index and that node is visited since the last jump, then we count it as a possible node to jump to. And then we loop over all possibilities, starting at 0. So the total number of times that we go through this loop is equal to ways to advance, which started at 1, which then corresponds with I is 0, where we just advance. And all the others are then the increments which represent jumps. So for all the other values than I, we get here. And then we just find out the ith jump target, which means that we again, just like here, run over all the even indexes and do the same test as we did here. Do that here. And we keep a counter with k, and if k then is equal to the current I, then that means that was the reason why we incremented. So in that case, we're going to jump to j. And I'll do the break. We just jump to the jump target that was set here. And then the problem is that this case, I equals 0, means that we just want to call advance, but sometimes that is not possible. Namely, if the current index is even and the current node is already explored in the current direction, then we want, normally I would do an handle abort h direction, which means that we are advancing is off the table. And doing a continue here, the idea was that I just continue this loop and basically skip I, and then let one of the jumps handle it. But it is possible, I think, that for exactly this condition, it is possible that the current node is the best minimum. So in that case, I do want to be able to jump to myself. So this should be allowed in that case. This. A bit confused though, because I thought this would really only happen when we reach the edge. suppose we are not at the edge, so we're somewhere in the middle. Is it then possible to run into a node that we have already explored in that direction? Yes, it is, but try to find this in the real code. So what does this mean? It means that we enter this function and then exit it. Exit it with value true. Bloody program is again too complex. I think it is has to be a jump extreme or local extreme. Jump local extreme. What? Oh, wait a minute. I think it was extreme jump. Yeah. Yeah, we have it. So we get in a local extreme which is already explored in the current direction. Well, apparently that can happen. So that would be this case. First you check if they're explored in both directions, and then we are finished. And if that's not the case, then it is possible that it was already explored in the current direction, in which case I'll call handle abort H direction, which changes H direction and then jumps to the handle local extreme jump again. So it does a jump again to the best extreme, to the best minimum so far. It doesn't have to be at the end then. But then how is it different when it is at the end? Because I think we could be in a minimum, and it could be the current minimum. This we just, the only thing then we do is swap H direction. This would happen, for example, if the best minimum is already explored to, say, the left, and then for some reason we jump back there, still going to the left. I mean, God knows, don't ask me how, but that would be possible theoretically. And then we get here, and then it says, okay, let's go right, because left is already explored. It would actually jump to the best minimum again, or you would do this and then do this jump, but it wouldn't be a jump because we would already be there. Already be in the same minimum. And then the case where we are at the end, that would be where we run out of energy. Guess I can safely search for energy. Yeah. So the update energy thing can decide if it must check energy. That so if that happens, then we are at the end. That's, well, assuming that in the other program. And then we mark it as explored in that direction. And here we return false here, which then means that we get again in handle abort H direction, which just toggles the current direction and jumps. Can this jump to itself? Jumping to the best minimum, I think it can. This is theoretically again the case where the best minimum would be the minimum where you're in at the moment, which it can be at the edge. So basically two cases then. Either we end up in an... I don't think it makes a difference there. So we end up in any node where we have already explored the current direction, and I want to do a jump. It is allowed to jump to itself if the last jump was to that very node as well, right? Yeah, I think so. Basically, the only reason that we are not allowed to jump to ourselves is because of the usual reason that we jump, which is when we found a minimum where that is worse. Hello, MJ. It's also complex. What the fuck? Okay, I think I get it. So if the current index is even, it means that we are in a minimum, and the current direction is already explored, then I want to simulate a jump, and I could just continue, which simulates all the other jumps to anything but itself. But I now also want to allow jumping to itself. And I think I can just use I equals 0 for that. So what we're going to do is explicitly jump to ourselves here, if that is allowed. And it is allowed in this case. So what I should do here is if the current node is visited since the last jump. So then I want to jump to myself. Let's inverse that. So if it is not the case, then I can continue. Otherwise, I want to jump to ourselves. Now to check that jump does the thing that I expect in this case. So it increases the generation. It sets the index to what it already is. And it changes the direction. This is the most important thing. And it prints it as a jump. Well, whatever. Where the set current index. Also called set visited. With the old jump generation. No. Jump generation was already increased. So it updates basically the visited thing, marking it as possibly the best minimum. Well, at the moment it just is, so we are allowed to jump back there. Can this happen? That it is the current index is old? I don't think so, because that would be index, and we jump to the current index, and the current index was determined to be even. So I don't have to check the return value. Right, and then the running out of energy in case, so the thing on the edge. Where was that detected? That's an advanced thing, right? We just want to advance. So the current direction is right, and oh, well, okay. It's if we call advance, and we really want to advance. I mean, we just detected this case, and yeah. Java. This is C++. It's like in the first word in the title of the video. If the current direction is right, and that direction is already explored, and we make an arrow out of that. Same for left, which is kind of strange because I just said that that was okay. The only thing I want to do then is to abort going in that direction. So maybe either I can delete this because what you really can conclude is that we just should never call at once in that case. Or we come from here, and that's an else of this if, which means that it is not explored in the current direction. Unless this is false, then we would still call it once. So, okay, I'm doing that on purpose. So I'm testing if it is even, because if it is a maximum and we have it already explored, then I call just at once anyway in order to be triggered here again and then throw that exception. So we can leave that. So this is the case where we reach the end of the list. We're going right, but we can't go right because we're at the end, or we go left and we can't go left because we're at the beginning. Then all this does is set explored, which is not exactly the same as aborting, because aborting at the very least switches the direction. And it also jumps. Right, so what should I do here then? I think I want to simulate still then a jump to our cells. So especially from calling here. So basically you want to still do a jump to our cells instead of advance. Exactly this. Which then, let's check that again. I don't think there's any difference though. That's increased. Yeah, looks good to me. So advance could call jump on the current index in that case. But it also has to set that it is explored then. Okay, let's see. We have improvement though. Wow, it stops. Crash maybe. No, no crash. Now let's see what happens. So we can start in node 0 and go left, I think. Can't go left, therefore we jump to 0, which I just coded, and go right. And then we just go right, we go right, you go right, you go right. And now we can't go right because 4 is the last one. So we jump to 4 and reverse the direction again and go to 3. And then we stop because 3 is odd and we were already in 3, which is a mistake. So the algorithm is wrong. Another possibility was that instead of jumping to 4, we jump to 0, which is even, it's allowed, and switch direction. I'm kind of missing seeing what the direction is that it wants to do. Let's print more. Let's print a little arrow behind each node that says what the current direction is. So every time we print the current index, get current index. Only 2 of them possible. This is an advance. It should also be done. Oh, here. I'm jumping index. Yeah, I could use current index here as well. But it's not necessary, I suppose. Nevertheless, let's call a function like print. Bit simplistic, but okay. So it print with that as string, and then you can just use the current index. We can get the length also from the string. So the print can replace all of this. Just add it here. Yeah, well, I don't know, arrow. Would have to set the string length to 0 here. And then I can call print with an empty. Yep. And then we can print a little arrow here, depending on the current direction. So we have the current direction here, which is a boolean. Yeah, print's already called there, so let's just move these up. It's a good question actually. What is current direction? Okay, it's just direction, so left, 0 is left. Where do I have my file with strange characters? Man. Nope. That's annoying. I made a file specially to make it easy to get often used UTF-8 characters. Oh, there it is. I just overlooked it. Oh, here it is. Overlooked it. Surely I have an arrow here. Yeah, there. Left and right arrow. Let's use. Don't tell me I don't have an arrow that points. Oh, the arrow that points this way. Ugh. So I have to use the double arrow then. Nah, why not? Oh, wait a minute. I think I'm still... Yep. So 0 is left, and then the other one is right, obviously. C code. String. Blip. So now we see. We don't actually, because I'm pretty sure this should have been the other way, pointing the other way. Oh, this is the true value. Yeah, it's the other way around. Oops. What? Nah, whatever. This is left. There. So we start with in 0 going left, which is not allowed. Here we go right. Then we go to 1, 2, 3, 4. Can't go any further, so we jump to 4. No, apparently 4 is better than 0, so we are never allowed to jump to 0 again. But yeah, going left makes us end up in 3, and we're already in 3, so stop. Optionally, we could have jumped from 3. I don't think so. Oh, okay. The number of spaces is now wrong because we have to add one more to the length, to every length. So we can jump to 4, but we could also jump to, for example, 0. And always swap the direction. But that was already explored, so we swap it again. And then go to 1, but that was not okay because we were already in 1. Okay, man. I'll see what I would say. This is an odd index for the second time, yeah. Or we can jump to 2. Which is allowed because that could be the best minimum. But then if we go left to 1, then again, we were already in 1. Other jump points don't exist, so there's only 1, 2, 3 even indexes. That's the only 3 points where we can jump to. In this case, we were allowed to jump to ourselves, and then also tried 0 and 2. This one goes from 2 to 0, and then to itself and 1, and we stop. Or why not to yeah, we can jump to from 2 to 0. We cannot jump to 4 because we were never in 4 yet. So apparently those are the only possibilities. Starting at 0, going left. Just have to immediately turn around. And we have to continue from 0 because we never visited any other node yet. So we can only go to 1, and then we can only go to 2. And then we might jump back to 0. Or we can go to 3 and 4, and then we can jump to ourselves or 0 or 2. Yeah, looks correct. Then the next possibility, because this program is brute forcing every possibility, right? So the other possibility is that you start in 0 and start with going right. So then we go immediately to 1, 2, 3, 4. So the same thing happens. Except then when we jump to 0, before Oh, we jumped to 0 and swap direction. That was okay. That happens still. And then this is the same as that one, and this is the same as that, or the other way around. So it looks okay to me. We can start in 1 going left, which means we go to 0, and then we can't go further, so we turn around, and then we go to 1, and yeah, we were already in 1. Okay, so we can start in 1 and go to the other way. So we go to 2 and then 3 and then 4. Now we don't jump back to 0 because we were never in 0. So we get only these. Or we start in 2 and we go left, so we go to 1 and then 0 and then the back. Or from here we go to 2 because we were there, and then 3, 4. That's an interesting one. Same thing. Well, I think it works, except for all the errors, of course. Now, all of these errors come because I did not implement correctly yet marking when a node is explored in a certain direction. But I think I got everything else. So the whole brute force thing. The starting point is obviously okay. We start twice in every node. One's going left, one's going right. And when in an odd node, we always just advance. And in an even node, we either advance or we jump. And we can jump to ourselves in this case. Yeah, hopefully it works, right? Also find back that we run into not the end, but a case where we jump to an even thing and then immediately jump again because here I think. It's actually unlikely because I'm not marking anything being explored in a certain direction. Except, well, sometimes. It's again a 4, right? You don't see a jump 2 and immediately followed by another jump. Okay, let's start implementing the thing that a Claude AI did not get. And then I mean not get at all. Like prompting me to stop paying for it, basically. To decide yet totally, but yeah, I was really like, dude. What a waste of my time. So what I wrote this thing is I have a linked list of nodes where each node is either a red, which means an even index, or green, which means an odd index. Red and green nodes strictly alternate, as odd and even indexes do. We start at a random node and then go into a random direction. We can blow this up. Do I even have viewers? Let me do a quick peek. I have a few viewers. Okay, I'll blow it up, text a bit. That works. We start at a random node and then go into a random direction. That would be the start up. Each node can be marked as being explored towards the left or being explored towards the right. The rules for marking them like that is as follows. I'm going to implement it now, but let's skip ahead. The move rules to go from one node to the next are as follows. We start in a random node and pick a random direction, already said that. Then we advance one step to the next node in that direction, unless that direction was already marked as explored. Or sometimes at random we are in a red node. In that case we jump back to an already visited red node, see point 4 above. Yeah, it's kind of implemented, right? Okay, if we try going left, right, but this is not possible because we're at the end of the linked list, then we mark the current node as explored into that direction. And I'm pretty sure I already implemented it. So this is about nodes and about being explored, which means that we call set explored. And I don't have many of those calls, but we do have them here. And yeah, that's the only one. And that is when we reach the end of the list. So we're going right, but we are at the end, and then we say export right, same for left. So that would be point 1. Point 2, if we are in node X and go left or right, arriving in an adjacent node Y, so that would be an advance, then X is marked as explored into that direction. So if we call advance, and advance is successful, which means that we did arrive in Y, then X must be marked as explored in the current direction. There's an advance here. That's the only bloody advance. And then if it is successful means that it doesn't throw, of course. It returns void. Well, let's not care about throwing. I could say in advance that call to advance is successful then. But yeah, we convert it to a jump here. That would not be successful without throwing. When does this return error? We can actually go there, yeah. So only when this happens, I think, set visit is set by a call to set current index as a result of a call to advance, and that returns false, then we did succeed. Which means that Control T, yeah. It means that we just changed the index by this amount as a function of get current direction, and that direction was not changed by set current index if it returns false. And set visited does do a lot of things, but no, it doesn't. Just direction remains the same. So if there is not an error, then we get here, and then we know that the previous value of get current index now must be explored. So I'm gonna do This is state. Yeah, of course it's state. So I'm gonna do nodes. I'll just store it. Previous index. Set explored. Get current direction. Hmm. Point 3. If, while going left-right, we already saw a red node, then the new node is marked as explored into the opposite direction towards the red node. For example, we are in X, and X is red. We go right to Y, which must be green. Then Y is marked as explored towards the left. Then we go again to Z, and also Z is marked as explored towards the left because we already saw the red X. However, if we begin node X and X is green, then go to the right to a red Y, then Y is not marked as explored to the left because we didn't see a red node yet. Yeah, so that's also advanced. I hate to add another boolean to state. I want trying to keep it small. But it's probably absolutely not worth it to keep it small if that costs a lot of time and thinking and is error prone and stuff like that. So let's add to state a new variable. Minimum, which then has to be initialized to false. Every time we jump, it must be set again to false. Every time we set the index, current index, to an even value, then it must be set to true, including this immediate point. The feeling I could use jump generation somehow, but okay. Should do it this way. So minimum here being so red. So now if we see an even index, we arrive in an even index, then we set the minimum. So even index or red, all the same thing. It's reset after a jump. Is that correct? Yeah. And so now that variable is set, I think. So the new node after an advance is marked as explored in the opposite direction if this is set. And the examples don't count anymore. I mean, whatever. Examples. Who needs examples? So we go to advance. And we say we are successful. I think that was at this point basically. Or unsuccessful that point, yeah, so that is here. This is the successful, the point where you are successful. So we arrived at that, and then we can say if minimum, then the current node must be explored in the opposite direction as the current. Do I have an opposite direction? Nope. Let's be lazy. Nope, that's the wrong one. If while going left or right we already saw a red node. Yeah, let's make that And the new node is marked as explored into the opposite direction. Well, new node to explored. Should be it. Has nothing to do with a jump, correct? No. Something must go wrong here. Or not. This is in advance. No, so nothing goes wrong. Just this is cool. A jump does not do this. Yeah, okay. And then lastly, we have point 4. We also go into the same direction, except that at some moment it can happen that we jump from a red node to a previously visited red node. If that new node was already marked as explored in both directions, the algorithm stops. That's, yay, we do that. Otherwise, we continue from there in the direction that wasn't explored yet. Yes, sort of. I'll call, just invert the direction, and then if it turns out that that was explored and the other one, other side wasn't, then we turn around again. So then we do this, yeah. Note if that point, note that if at that point it is discovered that the next node was already visited, then we go there immediately. You would anyway, but this is a special way of moving to the next node. I didn't build that in yet. However, point 3 is applied nevertheless. The new node, which must be green, is marked as having been explored into the direction of the last red node. Okay, so this is just a special case for if after a jump we advance to a node that was already visited and is green. I think that currently I'm throwing an exception, but we shouldn't do that apparently. Because this is a special way of moving to there. It must, however, be marked as being explored. Right, see if I get that. So doing the advanced thing. And then, well, we run into this. So the special case then is that we just did a jump. I don't want a special case set here. Could try this maybe directly after a jump. So if we do perform a jump, then normally, that's not the question, who's calling this? being called from here, line 205 and 225. And 120. Too many. That is an advance turned into a jump, so that is possible. And then we have the jump here, which is basically also instead of an advance, also goes to the current index. This is the only real jump to a different index. To the advanced scooter jump, this is a jump. Both cases immediately after the jump we get here, which calls run again then. And after this jump, also called run. And the other jump that I had, that was part of advance. In that case, I don't know that I jumped. Time for a Boolean, I guess. That's still problematic. I can hardly set it to be explored already before we advance there. I guess I have to make this again a new member variable. Which then must be set every time before we call run. So run is being called here, which means that it is set here, or it is set here, and therefore in this block as well. So I don't even have to set it to false here, because if we go in here, then either we set it there or there. And if you go in here, we set it here. The initial state has a run, and it's it. How about here? Did we just jump or not? No, I mean, it doesn't matter. It's not going to happen that the next node has already been explored in the initial state. So let's just set it to false. So we have a new boolean in state. Just jumped, which I'll set to false as well. Okay. And then inside the run, yeah, really. Inside run, yeah, we just call jump. Or we call advance. And only in the case of advance, I'm really interested in using just jumps. But the old value is still set at the moment we call jump here, and as well as here. As well as here. Now we do call jump. Then, yeah, nothing, just not used, I think. Should not be used, it's okay. If I call advance, however, then we might run into this. So now this is okay if so we jump. The new node was already marked as explored. Both directions stop, otherwise we continue from there in the direction that wasn't explored yet. Note that if that point it is discovered that the next node was already visited. That's something else than explored. Suppose that being explored is still wrong. Just have a look at visited and then we go there immediately would anyway, but okay, now we don't go there immediately. I just call advance. But I remember that we just jumped. So if it just jumped and it is visited, then it is kind of a special thing. But I'm currently I'm not doing anything special if it is visited or not. I just set it again. Is visited. And I think the whole thing can be ignored. 0.4, I mean. So 0.3 still applies. So if you were successful, then so minimum must be set, and that is set because it is set after the jump. And then we still do 3. And this might be double, but I don't really care. Now, feels like I implemented everything, so I'm extremely curious now what goes wrong. Nothing. It's kind of a boomer, I must say, because my current code does have a bug. And I had hoped that it would find that bug and that bug alone. So why is it not finding that bug? Yeah, let me run over what happens anyway. We're in node 0, we go left, can't go left, there we go to node 0 and we go to the right instead. Arrive in 1, you arrive in 2, arrive in 3, arrive in 4, we can't go any further, so we consider going the other way, but yeah, and then we stop. No, good enough for me. I think done should kind of print the best. Actually, no. Well, no. This is the best minimum 4 because that's where we jump to. So the result of this is that 4 turned out to be the best minimum, and this run 0 is the best minimum, and this run 2 is the best minimum. And then it's possible that from 2 we jump to 0 and are done, which means that it was marked as being explored in that direction. Yeah, which I guess it is. This looks wrong. This definitely looks wrong. If we start in the maximum and go left, then reach a dead end, then we are not done here. 0 should never have been marked as explored to the right. Jump, Prince, jump. Advance, either throws, calls jump and returns, or prints an arrow. We don't have anything else in jump and advance. So explored. Shall I use for explored? This is explored. Or in case I debug this in the debugger. And I need to print the index, of course. And then again an arrow, depending on the direction. I'd like to use a different arrow. They do have double arrows, but not that fat single arrows, it seems. I could use this one. Oh, wrong one. That one. I could also print which thing is exploding in which direction. Not at the moment that we do it, but just the state. Maybe print that directly after the index when printing. Positive direction. Yeah, where did I copy stuff from? Oh, here. There's again this arrow. Current right, sorry, I meant right. Export right. Maximum laziness. Just debug code anyway. Okay, my index is missing here, I think. Square brackets with an arrow but no index. I think I'm printing an unsigned char or something. Where do I do that? No idea. Here. Yeah, so that's why I use get index. It's not what I wanted. Looks, all my direction arrows are gone. Yeah, there's one here, but that's about it. What? Oh, I'm not printing it if there's none. That's a problem, I think. It's not good. Okay, so I just have to search. I want to search for the double arrow, which we have here. Ta-da! It's not too lazy. So in 0 going to the left, mark as explore to the left. If you want to read that, it probably would be better to put the index on the other side. Yeah. That was a call to set explored, right? Get index. Let's put that on the other side. So now 0 going to the left. Mark as being explored, having been explored. To the left, node 0. And a jump to 0 with being marked. So you see that's still back now. And now going to the other way. Maybe I should put that one also in this one, so you can more easily have a pattern recognition. And then the difference is that if you have square brackets, and it is being done, being set, and otherwise it has already been set. Yep, so that would be just print. Hey, Clement. Oh, but then you get that. Not sure I want to see this arrow here. Where did that arrow come from? Oh yeah, I wanted to have that arrow here, I think. Yeah, that took a long time. Maybe I should just go to bed. Finally realize what is the problem. Definitely want to start printing arrow. And then I'm not sure anymore. If I want this, I mean. But okay, so now we have it. 0 going to the left. Mark 0 as being explored to the left. Jump to 0, which is explored to the left. Going to the right, which means that we go to 1. And still going to the right. And then we mark 1 as being explored to the left. And we mark 0 as being explored to the right. Now that's an interesting thing. This should only happen after finding 2. No, maybe you already found 2, but you didn't print it yet. Yeah, my square bracket should be clearly at the place that causes it to say. So where do I print my square brackets again? I have no idea. Just look for it. In set explored. Well, it's after the print. So we first do a print and then we call set explored on the current index and the previous index. Let's turn these two around, so it seems a bit more logical. But if we see those things, then that is as a result of arriving in whatever this arrow is pointing to. Arriving, yes? So arriving in the current one immediately sets it as being explored in the opposite direction. But only if we saw a minimum. Okay, so arriving in 1 sets 0 as being explored to the right and 1 as explored to the left, because we saw a minimum, aka 0. And then we go to 2 and we still saw a minimum, so this one is also marked in that direction. And so on, I would say. And then this thing is printed before the jump, because we, if you just run into an end, then we do this, and here we run into the end, so we do this. So I could print something in between here that says, or here in front of this, that says, hey, we reached the end. Like a vertical bar or something. And then this is again completely off. Absolutely no clue anymore what indentation should be. Well, it should be this. Should be all the way over here. But we are printing a lot now. Yeah. Should go to bed. I think I will. Let me just play a quick game of chess, and then in half an hour maybe I'll be in bed. This guy is not moving. Oh, finally he's moving. The English opening. I'm gonna play this anyway. Yeah. I don't like this push, of course. But what can you do? I want to cross. Oh, okay, and why would I not go here? Is it even a threat? I could take a bishop over it, like Tok. Could defend this point? Not really. Well, with the rook. That is true. Probably not worth moving my piece twice. I still have to develop my queen. Let's put that thing here, I guess. Eyeing this point here. No, the open file. Then this pawn is pushed, however, and I go somewhere and I lose this pawn. It's, yeah, asking for the pawn push. What about the other rook then? It's not doing much here, does it? Is it? I'm not about to lose my bishop, by the way. Push this, I'm just gonna sacrifice, of course. If we would go back, that's not possible. My queen is kind of blocking the exit here. Have to sacrifice. Maybe we should just do this. Oh, really? Understandable, understandable. And I can't go here now because of the bishop. Damn it. Oops. Yeah, so I did run out of time then. This is not good. This is good. He did not want to lose the knight by going there. Yeah, well. What to do? Yeah, it can't be good for black, huh? But could go here and a castle, and then I have an attack. We could hope they castle anyway. Play my bishop already here. Can't push that yet, can they? They can push that. Oh, take. Bishop has to go. This bishop is blocked by my own pawn. We should just push this pawn now. Take with tempo. Can't be wrong. Can't be wrong. And then I can develop this bishop. But yeah, by then maybe they get too scared to castle. Looks like they don't want to castle. How can I punish that? Go here anyway. Defend my pawn. I'm gonna defend my pawn first. Safety first. Ah, they castled. Very good. Look at that attack. That pawn. Well, yeah, I guess it's a possibility. Usually this kind of thing loses unless you have an attack on this side, but black does not have an attack on that side, so... wants to win a pawn here, so take, take, take. Queen is here, black squares are well defended. I take here. I'm a pawn down then. Maybe I don't want that. Just go a step back first. So these two pieces just they don't do anything. I'm almost scared to lose now, or not win, rather. Because that would be really bad in a position like this. Yeah, okay, well, maybe you can take that. I don't care. Let's start my attack. About taking here, I just take back with the f1 and then I don't see it. I just have to use all my pieces. They don't have any pieces. Let's use the knight as well. It's definitely not going how I planned it. Oh shit. That is stupid. I thought I could give check here. After, if they take... But they, I can't do that. Because it's the suit bishop. Shit. Instant loss. Yeah. I don't know, man. Good move. Definitely a good move. Oh, yeah, right. I don't think I'm going to win this on time. I have this feeling. Yeah, stupid mistake. I thought I must have had something. I mean, come on, that was completely winning. How the hell did I give that away? Plus one, plus one, plus one. 1.5 plus 2. Yeah, that was a bad move. Plus 2.8 plus 3 plus 4. I did all Stockfish moves as well. Cool. Taking the rook. I should have taken with the rook. It was plus 4. Plus 8. That's what I mean. It's a completely winning game. Completely. Still plus 5, plus 5, plus, and I gave it away. This move gives it away. Yeah. What should I have played? Now I can sacrifice. Now I could sacrifice. Really? Then the other rook comes. And then we have a check. Then it goes there. And then I have this check. And then you go there. And then I sacrifice that rook. Oh, the... Okay, yeah, I've not seen that. No, I must admit. Oh, the fork here. Yeah. So what if you go that way then? I mean, this is just a fork, right? And then we win on material. Hardly. It's +6, but the material is not even. Oh, wait a moment. I win the bishop back here because this is a fork on mate in one and the bishop. No. Could move the rook back. It's unclear, I think. Still, the reason is probably king unsafe and the rook is not playing. That you were winning here. And now, what about the king just goes to the dark square here? How do we win that? Oh, we have the bishop then, yeah. Deadly as well. Same fork. That's hard to see. What if you just go to the side here? This is the best move and this one is not mentioned because now we take the rook and it's not as dangerous anymore. Yeah, still lose the queen. Now, nice double rook sacrifice. Gives 2 rooks on a pawn and a bishop. And then gets queen back, but also for knight, and then maybe get the bishop back, or then it's kind of unclear, I think. But so that's what I should have done. But I did the bishop. Did not attack my queen though, so now I'm still winning. Here I gave it away. Yeah. Oh yeah. I must admit I did this move. And only after I did the move I saw you could exchange queens. And then my attack is gone. So, and then a move later I think I did sacrifice the rook. Yeah. And now it's nonsense. Now it's nonsense. So I could sacrifice here now. And then takes my bishop. Nah, let's take the rook. Second one. Only yeah, or give the queen. Only move. And now we have again this check. Okay, only move. Now you have to do this fork with the queen. Ah, this is a very nasty attack. Yeah, now it's... What? Why is it a draw suddenly? Since when is this a draw? That check is not good. Whoa, you have to first cut off this square, then you threaten main one. Okay, but what if it just takes? Take back and now? Yeah, no, it's different. Yeah, it's deadly. So my rook comes here and then the queen attacks the same squares. If that is opposite of the king, you're like dead. And the king is driven that way. Or can go here, check, go there, and then it is opposite the king. So this would be mate, for example. Isn't it? Queen moves. Same. No, I'm gonna try this one. Oh, it just goes back. Yeah, well, okay. And then here again. Well, I know what I would do with... Okay, take here. Oh, we cannot take here, the queen takes. Wait, queen can't take, that's mate. So what's wrong with this move? Hey, what? I'm blind. Oh, it was check. You take with check. And I made one. Okay, yeah, can't take there. So it's just like a windmill thing they call that. Keep giving check. Has to go there, and then the rook can go anywhere where they want. Yeah, that doesn't make much sense though. Is this it? You can't take because it's made in 4. Wow. So yeah, that would be made here. You can give the queen, but let's not do that. So you go there, and then we just give check, go there, give check, go there, mate. Okay, so it goes that way, and then you give check again, and now we chase it towards the queen, or not. Let's give away rook. Seriously. Made in 10. Blink, 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 blink. This bishop is a lot more powerful than I had thought. Oh, yeah, right. Okay, now I can't go that way anymore. That would be mate. Giving the bishop doesn't make much sense. So let's go here. Take the bishop anyway with check. Go here. Check. Pick up the rook. That would be the same fate. You just give check again and you have to go there. Because you can't go there. So we try something. Check. Go this way. Check. Go this way. Made him 4 by moving the bishop. But well, it does threaten mate 8 in 1. But yeah, this doesn't work. That's made in 1. It's very interesting. You go this way. Also check. You can't run, but you can't hide. That would be a very nice mate. So put the queen in between. Wow. Yeah. I did teach my pupils queen and rook attacks 2 months ago or something. I must say this is a very, very, very nice position. It does involve a bishop, actually. Also a rook. So it made a 9, made a 10, made an 11. Made an 11 here. Yeah, I mean, I wouldn't even know where I would find it over the board. I have to admit, we have a rook down and we win. But if you would give me this position and ask who is winning, then yeah, I would say yeah, either white or it's a draw. So probably white then. But you can do losing moves. You must give check here, right? You must give check. Then if you give check again and just go back, you must again give check, right? I mean, if you don't give check, it's made in 1. If you move the queen, it's just mate, unless you give check. So that would be this. It's still winning for white. Whoa, it's still winning for white. That in between was attacked twice. Then you get this check. And we pick up the bishop. Not overly clear why this is +3 to me. Yeah, I was. Oh, damn it! I should have been in bed like half an hour ago, at least an hour ago, really. I'll be back tomorrow with